Okay, so I just want to do a quick little video where I go through some of the problems that you'll encounter on the pre-calculus review for the online Math 2410. I've tried coming up with review videos, but to have something that's short and really covers all of algebra and all of trig, it's just too complex. So this short assignment kind of touches on a couple different areas, and I'll just work through the problems on this assignment. Further, if you have if you need more help with an area that I kind of brush over on this problem, on a given problem, just send me an email and just say, hey, I really struggled with the pre-calculus review problem this, and I'll get you some other resources that can kind of help to review that. But otherwise, like I said, this is just, I'm just going to go over how to do the problems, assuming that you have all the skills able to do those problems. Okay, so looking at this here, this first problem, we are asked to simplify if possible. And let me change my pen color. That'll be the very, very first thing I do. Okay, simplify if possible. So we have negative 243 to the 3/5 power. So there's two ways that you can think about this for this problem. You can either take this as the cube root, so that, excuse me, the fifth root, that 5 in the denominator says that that's a fifth root. So I can take the fifth root of 243, and then I can go ahead and cube that. The other way you could think about it is I could do negative 243, raise that to the third power, and then take the fifth root of whatever that value is. For me, I like to think about which one is easier to do mental math wise, and mental math wise, taking the fifth root of 243 is going to be a little bit easier. So you can use a scientific calculator if you want. If you don't have one, then you might want to use a table of values. And like I said, just send me an email. I can provide a way to do this with mental math. But otherwise, when I look at that, the fifth root of 243, just really quickly, that's going to be a negative 3. So then I have negative 3 to the third, and that gets me with a negative 27. So then here we have a negative 27. And of course, on mine, unfortunately, the answer is already displaying. So for this one, we have 18. We need to factor the trinomial. We have 18a squared minus 89ab plus 36b squared. So when I look at this, one of the first things is I look at, is there a GCF I can factor out? And unfortunately, with this trinomial, there is no GCF that I can factor out. Next thing I look at is, do I have one of those special forms for a trinomial? And in this case, I don't see a special form. So a special form might be something where it's a perfect square trinomial. So when it factors, it would be, of the form a squared minus 2ab, sorry, apparently I'm a little rusty, 4ab plus b squared. If it's of that form, then you can factor it to be a perfect square. This doesn't seem to fit that though, because I do have a perfect square here and a perfect square here. So factoring this one's definitely one of the more complicated ones to factor. So what I like to do is I like to look at, are there any factors of 18 times 36 that add up to a negative 89? And if you're curious, I do have a MARF method that I use sometimes for factoring that works well. 18 times 36, that's going to be a really large number. So my default is to break that up and to say, okay, well, 18 is 3 times 6, 36 is going to be, and you could do multiple different, 3 times 12, or you could do 4 times 9. 6 is 2 times 3, 12 is 2 times 6, 3 times 2. Okay, so the prime factorization of the product of 18 and 3, I have 4 3s and 3 2s. So that would be a 2 cubed times a 3 to the fourth. The nice thing about having this prime factorization is now I kind of have a method for making a list. So I'm just checking to make sure that I didn't make any mistakes. Okay, so that's right. So this kind of gives me a list. So I know that for my factor pair that I need to come up with, I have 2 to the third and 3 to the fourth, I know that it's going to have the factor pair is going to have to consist of all of those prime factorizations. So what does that look like? That could look like, we could write our factor pair here. We want it to multiply to equal that 648 value, which is the product of all of this. And then we want it to have a sum of the middle term, which is that negative 89. That tells me since I'm going to have a sum that's negative, but a product that's positive, I'm going to have two negative values. So for my factor pair, I could look at, 2. And if I do 2, then I would have, or I can even do 2 squared, actually. Let's do 2 squared. So I have 2 squared is 4, and then I have 3 to the fourth, which is 81 times 2. That's going to get me a 162. Okay. Unfortunately, though, my product then at that case would be a negative 158, and it doesn't match up what I need. So I could do a 2 to the third, which is 8, and then a 3 to the fourth, I have 81. That actually does it if I make both of those negative. I realize this negative 166. So this is going to be a negative 89. So we kind of lucked out that we got it on the second try. That's not always going to happen. So then what I do is I rewrite this, and I have that first term is the same, the 18a squared, and the last term is going to be the same, but I split this up to be a negative 8ab minus an 81ab plus 36b squared. Now you'll notice that these you can combine them, but we're separating them so that we can factor by grouping, which is the next part of this. If this step doesn't meet, if you for some reason got a sum that wasn't correct, you'd run into some issues. Here I look at, are there any common factors between 18a squared and 8ab? And I group them together, and I see that 18a squared and this, they each have an a in common. I also see a 2. So let's see, what do I get if I have a 2? I have 9a minus 4b. I think at that point it's factored as much as possible. Then I group these two together, and I look at 36 and 81. So both of those have 9 as a common factor, and then they each have a b. So I'm going to take out, I can do either a positive 9 that I factor out or a negative. My goal is my leftover binomial factor to match up with this. So this is actually going to be, so I have 9b, this is going to be a 9a. I'm going to take out a negative so that I have that positive 9a. Then this is going to be a minus 4b. Now I have two terms, and they each have this common binomial factor of 9a minus 4b. So I'm going to factor that out of both of those. So I take out that 9a minus 4b, and I'm left with 2a minus 9b. And that's my factored form. And of course, the answer displays that as well. Multiplication is commutative, so that order doesn't matter. So that's the only thing for that problem. Again, I know this was kind of jumbled, so if at any point you're kind of struggling with factoring, this is just a brief refresher on factoring. So if you're kind of like, how did you do that? Then let me know, and we can work with that. Okay, let me just erase this so I have some more space to do the next one, because I got kind of congested on there. Okay, so for this next one, we want to factor completely. Again, and this one has two terms. So with two terms, you tend to have a special form, either a difference of squares, sum of squares, difference of cubes, sum of cubes. In this case, I see that that first term can be expressed, that 36 we can express as a 6x, that whole quantity squared, minus, and that 25y we can express as 5y squared. So because of that, we have a difference of squares form. So this is going to factor to be 6x minus 5y and 6x plus 5y. That one factors very quickly. You can use some variation of the previous factored form, like I said, but that's just trying to go and do a brief introduction. For this one, we have two terms, x cubed and 8, and that fits the form of a sum of cubes. So if you don't remember how to factor a sum of cubes, this is where, again, stop the video, send me an email, let me know. But here I have x plus 2, and then I have x squared, since this is a sum of using that form, x squared plus 2x plus 4. Okay, and a lot of times we're tempted to try and factor that x squared, that leftover trinomial. It never factors, it's always prime. There's been many a proof that's verified that. So that's prime. All right, now let's simplify this complex fraction. So when I see this, my first instinct is I can't really do anything unless it's factored, unless I look at the factors and see if I have any common factors that I can simplify. So what I always tell students is factor the fractions first. So for this one, we have this 9x squared. And let me switch out my colors too, because this is going to get messy. So this 9x squared minus 26x minus 3. I want to factor that. I would, just using my own factoring method, we get factors of negative 27 that add up to negative 3. So this is going to get me 9x squared. I'm going to have a negative 1 and a positive, oh, let's switch that, huh? Positive 1, negative 27. That'll get me that negative 26 in the middle. So I have minus 27x. And you might have a different way of factoring. That's okay. I'm just demonstrating one way of factoring. You just have to know how to factor. I'm never going to tell you factor this way and that's the only way. Factoring isn't something we cover in this class. So however you factor is great if you use a different method as long as it's accurate. Factor out a 3x here. We get a 3x. Oops. Actually, let's factor out a 9, right? 9. And then we have x minus 3. And then I look at this, and these don't have any common factors. They're what's called relatively prime. So I'm going to take out a 1 because I want to have two terms with a leftover common binomial factor. So when I do this, I factor out, I get x minus 3, 9x plus 1. Okay, so that's the factored form of that numerator. That's great, but we factored that, but we also want to factor, we've got this part factored, but we want to factor everything else too if we can. So let's now factor this 2x squared minus 7x plus 3. And again, whatever factoring method you want to use, feel free to stop the video and use your factoring method. So I look at factors of 6 that add up to negative 7. That's going to get me a negative 1 and a negative 6. So then I have 2x squared minus 6x minus x plus 3. From here, these two have a common factor of a 2x. So then that's going to get me an x minus 3. And then here we have a common factor of, I'm going to take out a negative 1 because then that's going to make this a positive x and a negative 3. And we have that common binomial factor. I take that out of each of these. I get x minus 3, 2x minus 1. Okay, I've got it factored. And I've just got one more that I want to factor. So I just need to find a third color. And I'm using dark colors because those seem to display the best, but unfortunately that means a lack of creativity in the colors I'm choosing. So we have 4x squared plus 4x minus 3. Okay, so factors of, here I'm looking at factors of negative 12 that add up to positive 4. I'm going to think positive 6 and negative 2. Again, if this is too fast of factoring, you're going to want to pause the video and just say, hey, I need some kind of refresher on factoring. Then I look at factoring by grouping. 2x is what I factor out. I get 2x plus 3. These have a common factor of negative 1, so I have 2x plus 3. And from there, I have 2x plus 3 as my common binomial factor, and I have 2x minus 1 left over. Okay, so the fractions are factored. I'm going to go ahead and just then rewrite this. And my trick with complex fractions is if I want to divide, I would multiply by the reciprocal. So what this would look like is I would have this 9x squared minus 26x minus 3. I'm going to leave it in that form just for a second, over 1. And then instead of this fraction bar, instead of dividing by this denominator, I'm going to multiply by the reciprocal. So I'm going to, this becomes multiplied by 4x squared plus 4x minus 3 altogether over 2x squared minus 7x minus 3. Okay, so now I'm going to fill in my factored forms that I have here. And just due to space, I'm going to actually put it, I'm going to erase this and just put that factored form right there. So I'm going to change this. This is going to become that x minus 3, 9x plus 1. I might be using an excessive amount of parentheses, and that's okay. And then this, we have this 2x. I'm going to erase this. And I get this x minus 3, 2x minus 1. And then lastly, we've got this factor up here. This is going to leave me with 2x plus 3, 2x minus 1. All right, and then let's just look at, do we have any common factors that I can cancel out? Within the numerator, I do see an x minus 3, so those are going to cancel. I have a 2x minus 1, those cancel. And then after that, I'm just left with this expression here. So I have this 9x plus 1, 2x plus 3, all together over 1, which if we FOIL these out and multiply them, we get that 18x squared plus 29x plus 3. And then we don't have to put it over 1 because any fraction is over 1. And I know I kind of squished this on there, plus 3. There we go. So that's how they get that. So you can put it over 1, but you know, any number over 1 is just that number. As far as the answers go, WebAssign ideally should accept either the factored form or the non-factored form. Sometimes it specifies how they want you to put the answer. In this one, they don't. Just make sure you write it correctly on an exam, because on an exam, I will give points for either one. I don't care if it's factored or not, unless it says factor and then you give an answer not factored. That's a different story. But okay, let's see. So we've got one more algebra one, and then it gets into the trig. So I'm just going to stop the video after this algebra one, and then I'll move to the trig. Will be the second video. So solving this equation, first thing I want to do, it looks like a quadratic equation. There's a couple ways to solve a quadratic, but the first thing is I want 0 isolated. So I have this 5x squared minus 23x, and then I'm going to add 12 to both sides. And I'm doing this vertically, and I know some mathematicians don't like vertical addition, but just due to space, I'm going to do that vertical mathematics. Okay. From there, I look at, can I factor? And you might be like, I don't want to factor 60 and look at factors that add up to negative 20. You could also use the quadratic formula. I'm looking at this though, and I see that this is going to factor pretty nicely, pretty quickly for me. But if you're not as quick on factoring, definitely use that quadratic formula. There's nothing wrong with that. In fact, that always works. So let's use quadratic formula. So then this says, you know, x is going to be equal to negative b plus or minus the square root of b squared minus 4ac. Again, if this is where you're getting stuck, stop the video and take a look at, hey, this is, I need a refresher on quadratic, the quadratic formula, solving using the quadratic formula, that kind of thing. Trying to move my camera so I don't. Okay, so we have negative 23, so this is going to give me a positive 23 plus or minus the square root. B squared is going to be that negative 23 squared minus 4 times A, which is 5, and C, which is 12. You see, all together over 2A, and that A is going to be 5. So from here, I get a positive 23, negative 23 squared. I'm going to use a calculator because that's a little bit more than I know off the top of my head. So we get 529, and then we have 20 times 12. That's going to be 240. So minus 240 altogether over 10. Okay, so then this becomes a positive 23. Almost made it. Square root of 289 altogether over 10. That 289, the square root of that is 17. So I get 23 plus or minus 17 over 10. First, I'll apply the plus. 23 plus 17 is going to give me 40 over 10, which gives me 4. 23 minus 17, that's going to get me a negative 6 over 10, which is a negative 3/5. So then I have a negative 3/5 and 4. That's not right. Oh, 23 minus 17 is going to be a positive 6. Oops, there we go. Okay. So that's it. So that's the algebra video, and I just kind of wanted to make it short. Again, send me an email if there's any point where you're like, hey, I need a little bit more depth in how to do that. I need some refreshers, and I can definitely help you out with that. Thank you.